Have you ever really looked at that little blinking box that connects all your devices? It seems so basic, right? Just a bunch of ports. But what's going on inside is actually, well, it's pretty brilliant. Today, we're going to pull back the curtain and see exactly how a network switch learns.
So let's get right to it. I mean, think about it. You plug in your computer, your printer, your game console, and stuff just works. But how? How does that simple little box know that your print job should go to the printer and not, say, your PS5? It feels like magic, doesn't it? But it's not. It's an incredibly clever process, and we're going to break it down right now.
All right, so the whole secret starts with one simple idea. Let's call it every device's fingerprint, because that's basically what it is. Every single thing you plug into a network has a completely unique identity, right from the factory.
And that fingerprint, it's officially called a MAC address. That stands for Media Access Control. And the key thing here is that this isn't some setting you can change. It's a permanent, physical identifier that's literally burned into the network hardware before it even leaves the factory.
Yeah, it's this long string of numbers and letters, a 48-bit number to be exact. It usually looks something like this. But honestly, don't worry about the format. The only thing you need to remember is this. It's like a permanent, unchangeable address for your device. It's a serial number that it can't fake or hide. And this is the only language a switch really speaks.
So how does a switch actually use these fingerprints? Well, it basically acts like a detective at a mail sorting facility. For every single packet of data that comes through, it looks at two things: the from address, that's the source MAC, and the to address, the destination MAC. That's it. It doesn't care about IP addresses, not at this level. It's all about those hardware fingerprints.
Okay, so every device has its own unique fingerprint. Got it. But this leads us to a big problem, for the switch anyway. Because when you first plug in a brand new switch or even just power cycle it, it knows absolutely nothing. It's a complete blank slate.
And yeah, this table right here, this is basically the switch's brain. And as you can see, it's totally empty. It has no clue which device is on which port. It's just sitting there, completely ignorant of the entire network it's supposed to be managing. So how does it go from knowing nothing, to being the super efficient traffic cop of your network? Well, this is the cool part. It builds its own brain. It creates its own map of the network completely from scratch. And that map, that brain, is called the MAC address table. It's really just a simple database, but it's super powerful. All it does is connect the dots. It pairs a device's unique fingerprint, its MAC address, with the physical port on the switch that it's plugged into. That's the whole game.
Okay, this next part, this is the real aha moment. This is what makes switches so amazing. You don't have to tell it anything. You don't have to configure a thing. The switch learns the entire network layout all by itself, just by listening.
And the way it learns is so elegant. Check it out. Step 1, a little packet of data, it's called a frame, shows up on one of the switch ports. Step 2, the switch just takes a quick peek inside and looks at the source MAC address. It just asks, okay, who sent this? And step 3, the instant it sees that, it jots it down in its memory. It says, got it, this MAC address lives on this port. So let's say a computer with this example MAC address sends some data into port 1. Instantly, look at the table. The switch creates an entry. Boom. It now knows for a fact, hey, that device with that fingerprint, he's over on port 1. It's literally building its map of the world one tiny conversation at a time.
And you got to remember, this isn't a one-time thing. This is happening constantly for every single packet of data that flows through it. The switch is just sitting there, passively listening and updating its map. That's what makes this so genius. It's completely self-managing. But okay, what does it do with this new map? All right, so the switch is a great listener. It's fantastic at figuring out where data is coming from, but that's only half the story, right? Now it has to use that brain it's built to make a smart decision about where that data needs to go.
Yep, exactly. So after it learns from the source MAC address, it immediately shifts its focus. It looks at the destination MAC address in that same packet, and it asks itself one very simple, very important question. Do I know where this is going? Is this destination in my address book?
And the answer to that one question leads to two totally different outcomes. If the answer is yes, I know that guy, the switch does what's called forwarding. It sends that data packet only to the one specific port it needs to go to. Super efficient, super private. But if the destination MAC is a mystery, if it's not in the table, the switch has to do something called flooding. It basically just yells the message out of every single port, except the one it came in on, hoping the right device hears it. It's noisy and inefficient, but hey, it's the only option when you don't know the address.
And that right there,
That simple logic of knowing when to be a sniper and forward precisely and when to be a town crier and flood, that is the absolute bedrock of how efficient networks work. That's what makes a switch smart. It's this beautiful self-correcting system that just works.
But wait, what happens if you unplug your laptop and move to another room? The switch's memory would be wrong, right? Well, it has a built-in cleanup crew for that. If it doesn't hear from a specific device for a while, usually about 5 minutes, it just assumes it's gone. It erases that entry from its table. This is called aging out, and it's crucial for keeping the switch's map of the network fresh and accurate.
So let's just run through that one last time, real quick. Every device has a unique MAC fingerprint. A switch starts with an empty brain, but builds a map, its MAC address table, just by listening to who's talking. If it knows where a message is going, it forwards it precisely. If it doesn't, it floods it everywhere. And that whole incredible journey from total ignorance to network genius happens automatically, over and over, in the blink of an eye.
So, knowing that the switch's memory is powerful but also temporary, it leaves you with a cool thought puzzle, right? What happens in the exact moment you unplug your laptop from port 1 and plug it into port 8? How does this whole learning process kick in to update the map almost instantly? It's pretty amazing when you think about it. Thanks for joining me.